Next, I'd like to invite Alan Amici up on stage. Turns out our careers have crisscrossed. So Alan is Vice President and CTO of Transportation Solutions for TE Connectivity. He is, at his core, a car guy, having spent 30 years at Chrysler. He holds an MBA, a Master's in Electrical Engineering, and a BS in Electrical Engineering from the University of Michigan. He has been the recipient of the Walter P. Chrysler Technology Award and is a successful inventor who holds 2 U.S. patents. At TE Connectivity, Alan's teams are working on breakthrough new technologies to enhance the connected car experience and to combat distracted and impaired driving, using biometrics and embedded sensors to determine the state of driver alertness. Alan, the stage is yours.
Thank you, Anna. Thank you for the kind introduction. Happy to be here in DC to speak with a nice audience like this. Thank you for inviting me. Talk about the future of mobility here. According to the World Urbanization Report, in 1990 there were 10 megacities in the world. So megacities is 10 million people or more. In 2014, there were 28 megacities, and the expectation is by 2030, there'll be more than 40 megacities in the world. So it's changing the way we think about transportation, this urbanization move. So what do we think about parking and traffic and congestion and pollution? It's causing urban planners to create strategies for smart cities. So strategies that include wireless connectivity, first and last mile transportation solutions, proving grounds for autonomous vehicles, and even incentives for green technology. Interesting companies like Uber and Lyft have created a mobility service that is very cost competitive and creates some downward pressure with respect to leasing or ownership or rentals. Car sharing services, which are really still in their infancy, can also create some downward pressure on the traditional ownership model. So all of these factors are coming into play, and they're really driving 3 aspects in transportation. That's alternative propulsion, advanced driver assist, and autonomous vehicles. So let's do a quick review or a look into all of those 3 areas. So alternative propulsion, you expect to continue the trend of moving away from carbon-based fuels, so diesel and gasoline-fueled internal combustion engines, and moving to electrification. There are companies, Toyota, for example, is doing some homework on fuel cell vehicles, and in fact, they have their cars released in California. You can lease or rent them. Fuel cell vehicles are a little bit expensive today, and there are some infrastructure issues associated with that we saw in electrification, but over time could be an interesting solution. Automatic transmission. So we have 8, 9, and 10-speed automatic transmissions. Probably the most capital-intensive component on a car, developing a new transmission. It's also the most variable cost, the most expensive part of the car as well. So 8, 9, and 10-speed transmissions have been interesting, and they've rendered great fuel economy for us. But as you move to electrification, you'll be using 1 and 2-speed transmissions. So fewer moving parts, less expensive to develop, and probably more reliable, actually. So electrification is changing the way automakers think about how do you engineer powertrains. Also, 12-volt technology, first introduced in the 1950s. So we have over 70 years experience with 12-volt electrical systems. Now with electrification, you're moving to lithium-ion batteries. So these are roughly 300 volts. And for electric motors, it's 300 amps. So it completely changes the power distribution in cars. So you need bigger connection systems that can handle high voltage and currents. You have big cabling. You have to cool the batteries. So again, a shift in how electric vehicles are engineered. National Highway Traffic Safety Administration issued a report suggesting 94% of vehicle crashes are caused by driver error. This is a well-known statistic that you've seen for over a year. National Safety Council issued a report that said in 2016 there were 40,200 deaths attributable to motor vehicles in 2016. This is a 6% increase year over year. And it's the first time since 2007 that there's been more than 40,000 traffic deaths in the United States. So even with the advent of advanced driver assist systems like forward collision warning and autonomous emergency braking and blind spot monitor and lane keep assist, along with other passive elements like airbags, passive restraints, including structural integrity, 4 times roof crush, put a lot of technology in the cars. Cars are infinitely safer than they were 5 and 10 years ago. You still have more, more fatalities. So the industry has not solved this problem yet. So, and they'll be looking for technology to help address this. So are there ways, to determine the proper levels of driver distraction? Can we anticipate critical intersections or critical situations coming up? So expect to see more driver-facing cameras and sensors so that you can determine the level of attentiveness of the driver. Also look for more vision systems on cars that are going to look at intersections or critical situations that can alert the driver that something unusual is happening. So autonomous vehicles, also an interesting space. Driver safety is largely dependent, in the form of semi and autonomous vehicles, largely dependent on efficient and effective management of data. Effective and efficient management of data. So you have a number of sensors on the car. There's going to be radar, LiDAR, there's stereo cameras, there's ultrasonics, and there's high-definition maps. All of this is coming into the vehicle. It's a tremendous amount of data that you have to process real time. A technology called sensor fusion, which will be a fundamental part of autonomous driving, semi-autonomous driving. This is the notion that you can observe an event with 2 different types of sensors or technologies. So for cameras, I can see an object and maybe classify that as a person. I can also use radar and get a secondary classification that says, yes, that is in fact a person. And so now I've increased my confidence that I have a person in front of me. I need to change the driving motion. But very important that we have a really good understanding of the technology there. Also, large amounts of data. So this also changes the data networks inside cars. So today's cars have the networks have about 500 kilobits per second is a typical data network in a car today. So this needs to increase 2, 3, and 4 orders of magnitude. So 100 megabits per second, 1 gigabits per second, even 10 gigabits per second are seen as necessary for moving data around in the car. So this, in addition to changing the electrical distribution in a car, it also causes automakers to rethink the way they do their data networks in cars. So this is the advent of Ethernet, automotive Ethernet, so moving large amounts of data in the car. Our colleagues at Intel are suggesting that autonomous vehicles will generate 4 terabytes of data per day per car. So 4 terabytes of data, that's 250 compact disks. I mean, it's a crazy amount of data. And our IT systems really can't handle that today. I mean, it really can't handle real-time assessment of 4 terabytes of data per day per car. So what this really will require is artificial intelligence and machine learning, along with some experiences, to sort this data and make it more manageable so that our data scientists and engineers can analyze this in the cloud, off-board, or it can be assessed on-board on the car. It's also driving tremendous increases in computing performance of cars. The computing power is probably 3 orders of magnitude higher with autonomous vehicles or semi-autonomous vehicles than they are in today's cars. So we have to think that. Companies are also looking at their architectures as well. So today you have a distributed architecture. There's a number of computers on the car. They're doing assessments and they're sharing data in networks. Taking a page from aerospace, companies are looking at, should we have a central server with racks? So it's an interesting proposition in how you move data around in a rack versus distributed through a car. There can also be some advantages in terms of over-the-air updates, and there's some other things. But this is an interesting space. So automakers are looking at new developments in terms of data networks. They're looking in terms of power distribution has to change. They're also looking at how do I architect a car? Do I do it a little bit differently or not? So technology innovation used to be the domain of the OEMs. So Ford, GM, Chrysler, Mercedes, and BMW, and Toyota, they were the purveyors of the technology. They would invent it, they would think it, they would engage tier ones to develop it, they do development in-house. This has changed. This has changed recently. You have big companies with deep pockets that traditionally haven't been in automotive are now on the scene. So Intel, Samsung, NVIDIA, Google. These companies are all developing with partners autonomous vehicle systems that they could develop this technology and then place it into a vehicle. In some cases, they're collaborating or cooperating with automakers. In some cases, there's some competition, depending on the automaker, if they're trying to do this alone in-house. So it's also changed the whole thought process of how do we do autonomous vehicles. So autonomous vehicles is probably the toughest problem that the auto industry has faced, the toughest challenge the auto industry has faced in 100 years of auto industry. It's got to be safe, it's got to be reliable, it's got to be bulletproof. There's a tremendous amount of software. The sensors involved are incredible. You're talking about connected car and municipalities, and it goes on and on. It's really a difficult proposition. What I'm happy to say is that we have the best and brightest, not only in the auto industry, but the extended auto industry, when we include companies like Google and Intel and NVIDIA and HERE and other partners like that. So toughest problem to solve. We must do it. It's really important because we have 40,200 lives each year depending on us solving the problem. So thank you for being a kind audience. Have a nice afternoon.